When we describe how to make a solution, when we are making a solution by dissolving a solid solute, we need to start with the desired volume that we're trying to create, and we need to make sure those units are in liters. So if our desired volume is in a unit other than liters, step one is to convert into liters. If the volume that we desire is already expressed in liters, then this step can be omitted. Once we know the volume in liters, we need to use this along with the molarity concentration in order to determine how many moles of our solute we are going to need. Third, we need to take this number of moles that we've calculated and then use its molar mass, the substance's molar mass, to convert that number of moles into grams. Once we have completed these three steps, then the amount that we have, the grams of our solute, is used as part of the answer in describing how to make a solution. So the number itself is not the full and complete answer, but rather describing what to do with that mass of solute is the final answer. So your answer to these types of problems should take the format: dissolve X number of grams, whatever the answer to your calculations were, of the substance's formula would go in the second blank, in enough water to make, and then the third blank would be the desired volume of solution. Now it's important to note in this statement that the phrasing is we're dissolving a certain amount of solute in enough water to make the total volume of solution that was indicated originally. You're not adding that much water, the indicated volume of water. That is not what molarity is. Molarity is amount of solute per liter of solution, solute and solvent combined. So if we take a look at an example, the question is, how would you make 500 milliliters of a 0.133 molar solution of MnSeO4 and water? So the first step is to convert that volume into liters. And so with milliliters canceling, we find that this is equivalent to 0.500 liters. Remember to keep in mind your sig figs for your measurements. Preserve your sig figs as you go through. We should not be dropping those zeros. Second step is to take this volume and multiply it by the concentration of our solution, the 0.133 molar MnSeO4, and when we complete this product, we find that we need 0.0655 moles of MnSeO4. Using the molar mass of MnSeO4, we can then convert this quantity into grams so that we know how much of the material we need to measure out on the balance. And we should come up with 13.0 grams of MnSeO4. Now frequently, we may think that I've reached the answer of my calculations, that's it, I'm done. But remember, the original question is, how would you make this solution? So the numerical quantity is only part of the answer. Now you need to take that information and the volume that you were intending to make and plug it into the template statement. So our final answer would actually be dissolve 13.0 grams of MnSeO4 in enough water to make 500 milliliters of solution. We can also make solutions from existing solutions, and to do this, we do this through a process called dilution, whereby we take a stock solution. This is a solution where we already know what the concentration is, and we add water to that stock solution in order to create a solution that has the desired concentration, and it will always be a lower concentration than the stock solution has. Now, because we are working with a set amount of a stock solution where we know the concentration, that means the number of moles of solute is fixed both before and after the dilution. So if we substitute in equivalent values for moles before and moles after, we know that moles is equal to the concentration times the volume. So we can substitute these identities in and we get the equation M1 times V1 equals M2 times V2. The ones would be the stock concentration and volume. The 2's would be the diluted solution's concentration and volume. So if we take a look at an example, what is the concentration of a solution prepared by diluting 35 milliliters of 0.150 molar potassium bromide to 250.0 milliliters? So we are starting with our stock solution of potassium bromide and 35 milliliters of it. And we are asked to create 250 milliliters of solution. What we want to figure out is, what is that resulting concentration going to be? And so if we substitute in our values and then rearrange to isolate the final molarity, we find that we should get 0.0210 molar potassium bromide. One of the most frequently used ways to use this dilution idea is in the creation of a certain concentration of solution in a certain amount. This is something frequently that you would do for an experiment or for research that you're doing. You need a certain solution of a certain concentration in a certain quantity. So this example here is a classic example of how we would use dilution. Suppose you wanted to make 500 milliliters of a 1 molar hydrochloric acid solution. How many milliliters of concentrated hydrochloric solution, which has a concentration of 12 molar, would be required? So once again, we start with M1 V1 equals M2 V2. We substitute in what we know, and the question here is now, how much of that stock solution are we going to need? So we're solving for V1 this time around. Rearranging your equation and solving, you would find that we need to measure out 41.7 milliliters of the stock solution. Now once you measure out this 41.7 milliliters of stock solution, it would be added to enough water to bring the final volume of the solution up to 500 milliliters.